Hi everyone, this is a video going through the Unit 2 test study guide on linear equations. So the tests for Unit 2 will be very similar to the study guide. So if we can understand and know everything in the study guide, you should be in great shape for the test. So the first 4 questions just ask us to talk about all the key concepts that we've learned in this unit that I expect you to know and understand on the test. They're not going to be phrased just like this on the test, but these ideas will come up and be very helpful. So the first question is, what makes 2 quantities proportional? And what do proportional relationships look like when graphed? Okay, so proportional relationships is what we talked about the first few weeks of the unit. You also were exposed to them in 7th grade. So proportional relationships, when graphed, I'm going to answer the second question first. When graphed, they look like straight lines that go through the origin. Okay? And the key idea of proportional relationships and 2 quantities that are proportional is that you can get from one to the other by multiplying by some constant number. In 7th grade, we called this the constant of proportionality. We can think of it as the rate of change or the slope now that we're in 8th grade. So it's the idea is to get from x to y. Between those 2 quantities, we just need to multiply by a constant, which is why the equation of proportional relationships take the form y equals m times x, where m is the slope, but it's also this constant of proportionality. So an example of this is if you get paid by hourly, right? So if x is the hours, the slope is how much money you get paid per hour, and then y is the total money that you make. Guys, so you can just multiply the number of hours times that constant, how much money you get per hour, figure out how much money you make. Okay, and in those situations, if you work 0 hours, for example, you get $0. Non-proportional relationships, we have some non-zero starting value, or Y-intercept, but proportional, it goes through 0, 0. All right, then it asks us to write down everything we know about slope. How do you find it from a graph, from an equation, from a table, from 2 points? What does it mean? So slope is a huge key concept in this unit. Okay, slope in general, again, to answer the last question first, slope talks about the steepness of a line. Okay, from a graph, we can pick 2 points on the line and find the vertical distance divided by the horizontal for any 2 points on the line. Okay, from the equation, it's the m in y equals mx plus b and just y equals mx. It's the number that x is being multiplied by. From 2 points, we have that formula, m equals y2 minus y1 divided by x2 minus x1, and that basically means you subtract the y coordinates, or the y values, you subtract the x coordinates, or x values, and then you divide or you take the ratio to get the slope. And from a table, if we have a proportional relationship, you can just divide y divided by x. When it's proportional, y divided by x. When it's not proportional, though, that's not going to work out. And instead, you want to find the change in y divided by the change in x. So in this case, the change here is like plus 2 and the change is plus 4. So you divide the change in the x, or sorry, change in y divided by the change in x when it's non-proportional. And that will work for proportional relationships too, so that's a good thing to keep in mind, is it's really, slope is about the change in the y divided by the change in the x. Awesome. All right, write down everything you know about the y-intercept of the line. That is our starting or initial value. Okay, it's where the line crosses the y-axis. It's the b in y equals mx plus b. And when we think about a point, it's the y value when x is 0. Because whenever the x is 0, that means we're on the y-axis. So it's the y value when x is 0. And then what's the general form of an equation in slope-intercept form? This is going to be very important. We have y equals mx plus b, where m is the slope and and b is the y-intercept. Okay, so that's just all the things I feel like I know that are important about all these concepts. This is the key thing we've done in our unit. Okay? All right, now let's see some practice problems. So these are going to be the kind of questions we see on the test. First, we have a car manufacturer provided information about 2 different car models. We have car A, which is represented in a graph, and car B, which is represented in a table. Which statement correctly compares the miles traveled per gallon of gas, which means gas mileage? Okay, so miles per gallon of gas. If we look at the x-axis, we're talking about the gallons of gas, and the y, we're talking about the miles traveled. Here, we have the same thing in the table. So when we're comparing these quantities, miles per gallon, okay, that's asking us to find the slope, which is also a rate of change between the 2 quantities. Okay, so in car A, let's find the slope of the line. For car B, let's find the slope of the line, and then we can compare. In car A, I'm going to pick 2 points. I notice this is a proportional relationship, but I'll still pick these 2 points. I'm going from 50 to 100. That's my vertical change, so that's a change of 50. If I'm not sure about that, I can do 100 minus 50 is 50. And then the change of my horizontal, I'm going from 2 to 4, so that's 2. So this means I'm going 50 miles in 2 gallons of gas. So slope, of course, is vertical divided by horizontal. For car A, it's 50 miles divided by 2 gallons. So that's 25 miles per gallon. Okay, and then I'm going to do the same thing for B. I have a table here. Again, we can see it's a proportional relationship. So to find the slope or the rate of change, I can just divide y divided by x. I have 60 miles in 3 gallons. So that's equal to 20 miles per gallon. Notice I could also have done the change in the miles. This is 40 miles divided by 2 gallons. And 40 divided by 2 is also 20. So we get 20 miles per gallon. All right, so car A gets 25 miles per gallon. Car B gets 20 miles per gallon. So which statement correctly compares the mileage? Car A gets 5 more miles per gallon of gas than car B. That sounds right. Car A gets 25 miles per gallon. Car B gets 20 miles per gallon. So car A gets 5 more miles per gallon. And we see these are all wrong. It's not 10 miles more. And then C and D are saying that car B gets more, but we know it actually gets less. Okay, so this question, it's multiple choice, but it takes a lot of work. Right? You have to find the slope of car A, the slope of car B, and then compare them. Moving on to question 6. Which equation represents the line shown on the coordinate plane below? Okay, so we got this line, and we're trying to find the equation of the line. Notice that this line is a proportional line because the line goes through 0, 0. So it's going to take the form of y equals m times x, where m is the slope. And we see all of these do take that form. So what we need to do is we need to find the slope of the line. Okay, to find the slope of a line from a graph, I pick 2 points on the line, and I find the vertical distance divided by the horizontal distance. Okay, here my vertical is 3 and my horizontal is 4, but I have to be very careful. Looking at this line, I see it's going down as I read it from left to right. So this 3 here, I'm going to consider it a negative 3. I'm going down. Okay, so then my slope is negative 3/4. So the equation of the line should be y equals negative 3/4 times x. So that's not what A says, that's positive. That's not what B says, that says 4/3. That is what C says, negative 3/4 times x. Okay, so we just have to be very careful there, making sure we're doing vertical divided by horizontal, and making sure that we notice whether the line has a positive slope or a negative slope. Okay, awesome. Let's go to 7. 7 is another question that is going to take us a lot of work. We are looking at 3 different linear relationships. So we are told that there are 3 swimmers are training for a race. One day, they all swim, each at their own constant speed. Okay, that's signifying that we have a constant speed. It's a slope. It's also going to be a proportional relationship because when you're swimming, it looks like in all of these cases, we are starting 0 miles run takes 0 minutes. Okay, the line goes through 0, 0. We don't have a y-intercept there. It's a y-intercept of 0. And this, we divide the y divided by x for all of it, we get 0. Or we get the same thing. So this is proportional. Okay, so this graph shows us how long in minutes it takes swimmer 1 to swim 3 miles. Looks like it really goes up to 5. We have swimmer 2's information in the table and swimmer 3 in the equation. For swimmer number 1, let's figure out how, we're comparing miles or minutes. So we're going to find how many minutes it takes for a swimmer to run a mile. Okay, so here's an example of this. Here we have this point. And I got these points. To find the slope, my vertical change, I'm going from 0 minutes to 20 minutes. So that's a change of 20 minutes. And I'm going from 0 miles to 1 mile. So it takes swimmer number 1 20 minutes to run 1 mile. Oh, sorry, to swim 1 mile. Okay. Then I look at swimmer number 2. It takes swimmer number 2 42 minutes, it's my y, to run 2 miles. So we can divide that to get our slope. 42 divided by 2 is 21. So it takes swimmer number 2 21 minutes to run 1 mile. And finally, we have the equation for swimmer number 3. It relates the distance in miles to the time in minutes. We get that the slope is 17 from the equation. So that represents 17 minutes. It takes swimmer 3 to swim 1 mile. So which of these 3 swimmers has the fastest pace? Hint, the person who swims the fastest takes the least amount of time to swim 1 mile. So often when we're comparing things, we think that it's best to have the biggest number, right? But we want to pay attention to what we're really talking about here. Where all of them, we're saying how long it takes to swim 1 mile. So the person who goes the fastest, it takes them the least amount of time to run 1 mile. So swimmer number 3, it takes them only 17 minutes to run 1 mile, where swimmer 1 and 2, it takes 20 and 21 minutes. Okay, so that's what I'm going to write here. Swimmer number 3 has the fastest pace because it takes them only 17 minutes to swim a mile compared to 20 and 21 minutes for swimmers number 1 and number 2, respectively. Awesome. All right. Flipping over to the back, we have a line goes through the points 0, 2, and 1, 6. Write the equation that represents the line. Okay, so we know the equation for a line in general is y equals mx plus b, where m is the slope and b is the y-intercept. So we need to find the slope and the y-intercept. All right, let's start by finding the slope. See how we don't have a graph. So this is a case to find the slope. We need to use the slope formula. We need to do y2 minus y1 over x2 minus x1, which really means we're just finding the change in the y values and the change in the x values, and we are subtracting them. Okay, so I'm going to label 0, -2 my first point, and 1, 6 my second point. You could do it the other way around though. And we're going to take our y value of 6 and subtract our other y value of -2. Then we're going to take our y value of 1 and subtract, then we're going to take our x value of 1 and subtract the other x value, 0. And when you do that, 6 minus -2, that's equivalent to 6 plus 2. So we get 8 as the slope. 8 divided by 1, which is just 8. Right, so the slope of the line is 8. Then we need the y-intercept. The y-intercept is where the line crosses the y-axis. So as we wrote down earlier, for a y-intercept, it's going to be the y value when x is 0. Because if I imagine a graph and the point 0, -2, that's going to be down there on the y-axis. So they're giving us the y-intercept here. It is -2, since we have the point 0, -2. Thus, the equation of the line is going to be y equals our slope 8 times x plus the y-intercept -2. Okay, awesome. Then we have question number 9. Line T and triangle ABC and triangle CDE are shown on the coordinate plane. Which statements are true? Select all that apply. So we have line T here. That's my whole line, labeled T. And then we have 2 slope triangles drawn on it. So which statements are true? Select all that apply. So we're just going to go through each one by one. So the slope of line segment AC. Okay, let's find that. So this is A, this is C, so this is line segment AC. Is that equal to the slope of line segment CE, which is right here? Okay, slope is about the steepness. Do they have the same steepness? Yes. Okay, these make this flat straight line. They're all on line T. That slope is the same as this slope, right? They're a consistent line. They have the same steepness. So that is true. The slope of AC is equal to 2/3. Okay, well, to find the slope of this line, I'm going to find the vertical distance. That's 3 divided by the horizontal distance of 2. So slope vertical divided by horizontal, that's 3 divided by 2, which is not 2/3. So B is wrong. Okay, for C, the slope of line segment AC is equal to the slope of line segment T.
Can I borrow your broom?
Yeah, go ahead.
Thank you.
Okay, the slope of line segment AC is equal to the slope of line T. So again, we have line segment AC is part of line T. You can pick any 2 points on the line to find the slope. So these are also going to be equal. They have the same steepness. Then we have D. The slope of line T is equal to CD divided by DE. Okay, so to find the slope of a line, we can pick 2 points on the line and find the vertical distance divided by the horizontal. So here's a point C, here's a point E. We find the vertical distance between them. This is CD. We find the horizontal distance between them. This is DE, and we would divide this vertical distance CD divided by DE. So that checks out. That is going to be the slope. We could figure it out. It would be 6/4. But it's not really about the number here. It's the idea that it's going to be this distance divided by this distance. And option E, the slope of line T is equal to AB divided by DE. Okay, so that does not line up. That does not make sense, right? Because we have AD is here, D is here. So we don't have 2 points that we're finding the vertical divided by the horizontal distance between them. We could pick A and E, but then we would need this entire length and this entire length, which we don't have. Okay, so that's not a vertical divided by horizontal distance for any slope triangle. And then finally, the slope of line T is equal to AB divided by BC. Okay, this is going to work out because AB is the vertical distance here, BC is the horizontal there. So again, you could also, to find the slope of the line, do AB divided by BC. All right, now we have question 10, which says write an equation for each line. Okay, so to make it clear here, this is the x-axis. Okay, this is the y-axis. And then we have 4 lines. We have line M, which is this line K, which is this line, okay, line R, this line, and then line P. And we need to write an equation for each of those lines. So let's start with line M. M is a line that goes through 0, 0. Okay, so this is a proportional line, which means the general form of the equation is y equals m times x, where m is the slope. So all we need to write the equation of the line is to find the slope of it. Okay? So if I pick any of these points that are clearly on the line, okay, I can see that my horizontal or my vertical change is 2 and my horizontal change is 1. So the slope of the line is 2 divided by 1, which is just 2. So the equation of this line is y equals 2x. Okay, yeah, that's all it is for that one. This is a positive slope. You want to make sure you're checking that that one is positive. Then we have line K. Line K is right here. This is my vertical line. For a vertical line, the standard form of an equation is x equals c, where c is the x coordinate for every single point on the line. So line K here, we see it's made up of all these points on the line. Okay? And this is 2 units to the left of the y-axis. So all these points have a x value of -2. Okay, so the equation of this line is x equals -2. Okay, Then I have line R. This is a non-proportional linear equation. So the form of the line is y equals mx plus b, where m is the slope and b is the y-intercept. Looking at that line, the y-intercept is right here. That is at positive 2. So I'm going to have y equals something times x plus 2. This is at 2. And then the slope, let me pick 2 points that are on the line. I have this point and this point. Between them, I go down 1. My vertical distance is 1, but I'm going down, and then right 2. So the slope is negative 1/2. Okay, notice this line is going down, so I have a negative slope. And finally, we want to write an equation for line P. Okay, line P is right here. That is 1 unit above the origin. This is a horizontal line. For horizontal lines, the general form of the equation is x equals a, where a is the y coordinate for every point on the line. And this is right at 1, so we get y equals 1. Okay, so these are the equations for the line. If you're unsure about any of that, you're going to want to look at the notes from Wednesday, November 17th. We have a summary chart of writing equations for the lines. And finally, which should be question 11, but here's a hint. The reason it says question 7 is because I copied and pasted this question almost exactly from the test, and it's question number 7 on the test, which is the last question. So we have that Juan's cell phone plan costs $100 to start, and then there's a charge of $25 each month. Question A asks, what is the total cost, startup fee, and monthly charge to use the cell phone plan for 2 months? Okay. So I'm buying a cell phone. I have to pay $100 up front. So I have to pay that $100 no matter what. And then I have to pay $25 for each month that I have the phone. And in this problem, I have it for 2 months. So we can think of it as 25 plus 25 plus 100, or 25 times 2 plus 100. Either way, that is going to give us $150. Okay. Then in B, we are going to write an equation to represent the total cost, y, for x months. So I need to represent this situation in equation form. Okay, this is a linear equation. It's going to take the form y equals mx plus b, where m is the slope, or the rate of change, and b is the y-intercept, or our initial starting value. So in this case, like we kind of saw up here, my starting value is 100. I have to pay that even if I get my cell phone plan for 0 months. The first day, immediately, I have to pay $100. Okay, and then every month after that, I pay $25 per month. So that's what I multiply the x, the number of months, by. Okay. And then finally in C, graph the cost of the cell phone plan over a period of 1 year using months as the unit of time. Be sure to label your axes and scale them by labeling each grid line with a number. Okay. So on the x-axis, this is going to be x months, since that's what I have here, x months. So this is my number of months. On the y, it's going to be the total cost. And I need to graph this data. Okay? So for 1 year period, that's going to be 12 months. so I can line this up. 12 months. And then let's just get a few points on the graph. We don't need to get every single month's data. We just need a few. Okay? So when it's 0 months, I still have to pay $100. Okay, so that I'm going to want to definitely have on the y-axis. I have that my slope is $25. So it's $25 each month. So that's a good thing to count by because that's what's going to change each month. So we know we'll have 100, 150. So I'm going to count by 25s here. 25, 50, 75, 100, 125, 150, 175, 200, 225, 250. Okay, it's not going to capture all the points, but it'll capture enough. So at month 0, it's $100. That's my y-intercept. At month 1, it's $125. At month 2, it's $150, like we already found. Okay, and we could just stop there. Like, this is enough points as long as we create a line. Okay, connect the points and extend it. Okay. I could just use a ruler, connect these points, and that's good. Okay. But I could also add some more points here. Okay, it's also good if we want to make the scale like 50 instead of 25, then we might be able to get all the months in this. But I know that a line extends forever. So as long as you have some of the key points like that, I'm good with that. Great. Awesome. All right, everyone. So the test is just like this. So study up.